So for many of you, this will be your last formal Java experience here. So I wanted to spend a little bit to talk about where you can take this from here. Some of you maybe loved the crap out of all this stuff. Some of you hated and thought it was crap. Either way is a valid opinion to some degree. This class is very unusual, and this is an overview. We spent a lot of time diving into a little bit of technology and then walking away from it. Each week was kind of a whole new thing we went away with. So let's be clear about what it means. So if you like Java, Java's everywhere. It started in embedded devices. It got really popular when the web became a thing. It went back into mobile devices. I mean, Android now is built on Java. There's actually some debate whether it should or shouldn't be, and whether it's part of it, and whether Google should be paying Oracle bunches of money for that. I don't know if that court case got finished yet or not. But Java drives some of the most secure, important apps on the web. You can find Java on the web, mobile, desktop, on the server side or the client side, in web app services, batch jobs. You can find it in games. Again, all of your Android stuff is built in Java, and then your productivity software out there as well, such as we'll see the Open Office applications. So you can run Java anywhere. You can run on servers, you can run desktops, you can run browsers or phones. Even within the cloud, Java fits very well into the cloud environment because it's built to be multi-threaded. It's built to be a virtual environment. So the cloud is a very popular place for Java applications to be. So you can run your Java code wherever. And on the web, there's the client side we talked about a little bit here with an Ajax. You can do applets or web start, things like that. The Java FX was a short-lived language that became kind of an interface to be able to do interesting UI type things. But mostly where Java is popular is on the server side. Servlets and JSPs are all the different frameworks we talked about. We use JSF. There's a bunch of other ones out there. We've talked about services, web services, and REST as an option in Java, and then using EJBs and JPA to help on the server side build those applications, though JPA does not have to be a web thing. JPA can be used in a desktop application. It can be used anywhere where you can access a database. Java does live perfectly well on the desktop. AWT, Swing, JavaFX. If you really want to know, OpenOffice is entirely written in Java. There's a lot of stuff that's written in Java that runs behind the scenes. Sometimes you can tell because you'll see a process that says Java. Sometimes they hide that. They build their own little wrapper of the JVM that runs for that. But it is a viable tool if you find the right place for going off and building it. And really, if you really love Java, the mobile space might be where it is. Originally, Java was built with something called the Java Mobile Edition. Android is the bigger part now. There are embedded systems that use things. There's a Java Card project out there that was trying to do embedded Java. Java has a history and a future in mobile and embedded devices. Android is really, I say it's a growing power here. Maybe it's probably eclipsed past what iPhone really is. And there's many different platforms. When you say Android, it's not even a cohesive platform. There's many different versions of Android from companies these days. So there's a lot of opportunities for development out there. There's a lot of opportunities for big expertise out there. The biggest thing I love about being a coder in Java is the ridiculous level of frameworks that are out there. There's quick ways to access new stuff. I have a framework I worked with recently that was allowing you to open up an Excel spreadsheet or modifying an Excel spreadsheet. I have used one that allows you to print PDFs quite quickly. I have a whole list of them here. So XML, working in logging or database, creating services, that's the document protection XML. Rules engines, very cool that you can basically externalize your rules from your application. You can even allow rules to be created dynamically. I once had a framework that I used to read barcode scanning inside of a Java application, be able to play with that a little bit. And so there's all sorts of cool things that can be done with that. Now, that's a technology view of this. There's really not too much that Java doesn't try at some point. There's stuff that hasn't been as successful at. But if you want to be a coder, using Java is a very reasonable tool. Even if you don't want to use Java, learning Java is a good bridge into other languages. If you want to go understand, say, Ruby is very similar to Java. There's a lot of principles that are the same. C++ is ridiculously similar to Java. So it's a good foundational language to learn from. Now, that being said, what about career spaces? Because IT is a bunch more than just code. Let's say you just did not love the code here. Let's say I got through stupid sockets, but barely. If you asked me to do it again, I don't know if I could. not where I want you to be, but my goal of this class is not to make you into the super Java programmer. If you do, that's great. I'm glad you came along. I'm glad you could do that. But the goal here is to give you an experience of what Java is, to test you against some of these tougher things, to see if you can pick them up and fall in love with it. And if not, at least be literate with it. Know what's going on. I'm not trying to, I didn't design the course here specifically, but in me executing this and putting these lectures together, I'm not trying to super challenge you to make you the best coder ever. I want you to have a good coding experience and see what it's like to build something more involved in a very professional way. But that being said, projects, you still have to find the scope for them. You still have to create architecture and design. You still have to do the code, but test it, deploy it, and then manage the whole process along the way. So if you love coding, find a job there. Build UIs, build server logic, do batch jobs, go build a tool. All great things to use Java directly. If you like a little bit higher level stuff, well, you can be an architect. That's my day job. I don't write code very much anymore. Mostly I give solutions to problems. How should we design these services to interact back and forth? What flow should these systems have? What do people do? What does my system do? You can do that for databases and information architect. You can do it for security. There's all sorts of high-level roles that you can go through coding, or you can try and jump into directly if you want to try and get a networking degree or something like that. There's also administration tools where I can learn how to be a Unix administrator, a Windows administrator. I can go become a database administrator or learn about WebSphere, WebLogic, Glassfish, something along those lines. At networking, I can architect networks. So I can go work as a network administrator, configure firewalls and set up routers. And I don't understand all that they do. They do very cool stuff. But there's multiple roles within that. Some might say there's some hierarchy or desirability. I don't know that maybe they're paid a little bit differently, but I know some people who are database administrators that are paid very, very well, if that's where their passion is. You just have to be great at your job and distinguish yourself. There's nothing wrong to say we need people to run cable. We need people to install operating systems. Not everybody needs to be a coder. I know some people who are really brilliant, great people who are well compensated who just don't love code. They don't love the constantly changing emergency fixes, the big time pressure. They like to just say, okay, once a month I'm going to patch some servers, I'm going to test those patches, I'm going to debug some stuff, but if it doesn't go this month, it'll go next month, sort of stuff. It's a different life, it's a different schedule. There's nothing wrong with that. There's a lot of great jobs inside of that sphere as well. If you don't prefer the technical stuff at all, you might love the process, and that might be where you want to be. You want to be a project manager, help people along, solve problems. You want to be able to specialize in how do we do these things? How do we organize these things? How do we do reviews? How do we make sure the project follows good patterns? And then there's testing. You might have taken the testing class, you might go take the testing class. It starts to get a feel for all the different things testing can do. The actually hands-on testing, doing performance testing, load testing. You can focus on just creating test cases. And even within testing, you might do some development. Let's say you want to be a developer, you're having a hard time getting a job. Consider finding a test job that'll let you do some automation. Prove yourself from the test team and then go get a job within the coding department from there. Get into the organization, understand the program and the product, and then go become a tester. The point being is there's all sorts of different things you can do with your career. There's all sorts of different things you can choose from this information. Having understand what coding is will give you an insight into what's it like to be on a project, but also it'll give you some sympathy for when there's a problem. Okay, well, the developers probably didn't mean to put it there. Go consider this. I've done a little bit of code before. Is it possibly like this? Or, hey, when you're writing the code, don't forget about when you do your database, externalize username and password because I want to be able to reset that as an administrator. Or when you're doing the socket connection, make sure you don't do port number less than 1000 because I'm the Unix admin, and if you do that, it's not going to work. All sorts of different things you might be able to learn from this and apply it otherwise. If you're going to be a coder, think about the rest of those jobs and how your coding can impact them and how you can be smarter and more strategic in how you're going to do that. All right, well, that's it here. I wish you the best of luck. I wish you to, if you love coding, to continue to investigate this further, play with applications, see what you can do. I hope to work with you someday as a peer. If you're not a coder, I also want to work with you as a peer. Just understand the good things that came from here, and maybe we'll see in another class we can talk about one of these other interesting topics.